Okay, 4.3, number 1. They give you a function and they want the coordinates of the local maximum. To find the local maximum or minimum or whatever of any function, you need to derive first. That means it's 3x squared minus 18x plus 24. Okay, you equate this to 0 and you get 2 roots. Okay, you can put this on your calculator, you get x is 4 and x is 2. Okay, so now we can make our table, the x, y prime, y table. And we put in our values, make sure they're in order, yeah? These come to 0, and now we can start testing. So we'll test a number here, so we could test 0, put it into our derivative, you get a positive number. Here if you test, for example, 3, you get a negative number. Here if you test 10, you get a positive number. So that means going up, then down, then up, yeah? So that means this point here, so when x is 2, yeah, this is a maximum, and this point here is a minimum. At x is 4, it's a minimum. Okay, and here they're asking for a maximum, so you just write x is 2. Okay, so that's the first part. Now to get the y value, you just take the x and put it in our original equation. So here you just take it to be 2 cubed minus 9 into 2 squared plus 24 times 2 plus 5. In the end you get 25. And that's the second part. Number 2. This is the same thing, so we're gonna derive. First thing you do with these questions is always derive. So 2x minus 4. You equate this to 0, so I'll just solve this manually. It's 2x equals to 4, so that means x is 2. Okay, now we can make our table. So x, y prime, we only have one value, so it doesn't matter, and then this gives us 0. You will test, for example, we'll test 0, you get a negative number, and we'll test 5, you get a positive number. So that means it's going down, then it's going up. Okay, now here there's asking for when the derivative is less than 0. Okay, when the derivative is less than 0, that means the derivative is negative. صح? And we look here on the table, when it's negative, okay, our x is less than 2. Okay, so we could say that dy over dx is negative when our x is less than 2. Yeah, so that's the first part here, when x is less than 2, when x is less than 2. And for the second part, they're asking for when the derivative is greater than 0. So you look at the table, when is it positive? It's when x is bigger than 2. صح? So we could also say that dy over dx is positive when x is bigger than 2. Yeah, and that's the next answer. Now this last one is when it's equals to 0. When it's equals to 0, you just give them the points that you have. So here equals to 0, it's at 2. So just say x is 2. Now f attains a local blank at which point? Okay, whether it's a local maximum or minimum, you just look at the arrows here. It's going down, then it's going up. So that means this point is a minimum. صح? So because it's going down, then up. So that means x is 2 is a minimum. صح? And to get this y value, you just take the 2 and put it in our original equation. So it's 2 squared minus 4 times 2 plus 4, and then you get 0. So 0, 0. Number 3, we have a function and they want the local minimum and maximum. First thing we do, I'm gonna derive. So it's 6x squared plus 12x minus 48. Okay, you put this to 0, put on your calculator, you get x is 2, and you get x is minus 4. Okay, so now we can make our table. Make it down here, the x, y prime, y. go minus 4 and 2. These give you 0. And we'll start testing for points. We'll test minus 10, put it in the derivative, you get a positive number. Here you get negative, and here you get positive. So it's going up, then down, then up. So that means that this point here is maximum, and this point here is a minimum. It's maximum at minus 4, and the minimum at 2. So here it's minimum at, we said it was at 2. This is the minimum, and it's a maximum at minus 4. Now part B. The function is concave up if and only value and concave down. When they're asking you for the concave up or down, that means you need the f prime prime, right? So you need the inflection point. So f prime prime, we said that our first derivative was this, yeah? So if we derive that one more time, we get 12x plus 12, yeah, because our f prime or y prime, you could call it whatever you want, yeah, was 6x squared plus 12x minus 48. Yes, we derive it one more time, we get this. Okay, now you take that, so 12x plus 12, equate it to 0, and you get the inflection point. So this means 12x equals to minus 12, x is minus 1. This is our inflection point. Okay, so now to test the table for this, we're gonna do the exact same thing. It's x and then y prime prime, and we put in our value minus 1. Okay, this here gets 0. We test a point here, you get a negative number. You test something here, you get a positive number. So that means our arrows, instead of having like straight arrows, we're doing like this. It's a concave, yeah. So that means it's going down, it's concave down when it's less than minus 1, and concave up when it's greater. Okay, so we just say that it's concave up when x is greater than minus 1, and concave down when x is less. Number 4, this is the same as the other question we solved. First thing we do is we're going to derive, so it's minus 2x. You equate this to 0, so it's minus 2x equals to 0, so that means x is 0. You can go ahead and make the table, so x, y prime, 0 gives you 0. Test a point here, you get positive. Test a point here, you get negative. And it's going up, then it's going down. Okay. So this first part, they're asking when the derivative is negative. So we look, when do we have a negative? When x is greater than 0. So we say that. And the next part is when it's positive. So you look at the positive sign. It's when x is less than 0. So we write that. And equals to 0, we just give them whatever value we got. Okay. And then to find if it's a local maximum or minimum, you just look at the point. It's going up then down, so that means it's a maximum. Okay, it's a maximum at point 0, we already know that. Now to get the second value, you take our point and put it in the original equation. So you put it minus 0 squared plus 4, so you get 4. Number 5, we're going to solve this normally. So y prime is 6x squared plus 6x minus 36. You equate this to 0, you get x is minus 3 and x is 2. Okay, so that means one of these is either maximum, one of is minimum, we don't know. But the thing is, here they're only asking for 1 point. Okay, they didn't say maximum or minimum. So how do we know which one they wanted? Well, they gave us a hint. They told us that the y value is 82. Okay, so that means y is equals to 82. So instead what we could do is we could just substitute. So we could write 82 is equals to 2x cubed plus 3x squared minus 36x plus 1. you could shift solve this equation and you'll get x is minus 3, and this is the answer that they want, minus 3. Number 6, the curve C, whose equation is given by this function, has an inflection point at x is what? When they want inflection point, this means that they want f prime prime equals to 0, okay? So f prime of x is going to be 12x squared, and f prime prime of x is 24x. Okay, we put this 24x equals to 0, so that means you get x is 0. That's your answer. Number 7, this is the same thing. We have a function. If we derive it once, so f prime of x is 3x squared plus 24x minus 36, and f prime prime of x is equals to 6x plus 24. Okay, equate this to 0, so 6x equals to minus 24, so that means x is equal to minus 4. Okay, because they're asking for an inflection point, so we put f prime prime equals to 0, so our final answer, x is minus 4. Number 8 here, they gave us a curve equation. They want the local maximum and the local minimum. Once again, first thing we do is derive, so it's 3x squared minus 6x. You put this equals to 0, you get roots are, the roots are 2 and 0. X is 2, x is 0, you take this, you put in your table, put 0, 2 of these two, put 0, and we start testing for points. If you test a point here, you get a negative number, here you get a positive number, here you get a negative number. So it's going down, then up, then down. Okay, so that means this point is a minimum at x is 0, and this point here is a maximum. So here they set a local maximum, so the maximum is at here. Wait, my bad guys, I messed up. These are actually the opposite. So here it's positive, here it's negative, here it's positive. So I'm gonna turn these around. It's minus plus minus. Okay. So now, yeah, my bad. So they said the local maximum. So you see here, the maximum is at 0. So at x is 0, and the minimum here, they're asking for the minimum. You look when it's going down then up, so x is 2. Now for this part here, they want the value when x is 0, so you just take the 0 and put it in f of x normally. So it's 0 cubed minus 3x, 3 into 0 squared plus 13 equals to 13. Let's take that, that's the answer. Number 9, this question looks different, but in the end it's actually the same thing. So first thing we're going to do is y prime equals to 3x squared minus 12x plus 9. Make our table, x, y prime, and here you get the roots are x equal to 1 and x equals to 3. So putting our values in, 0, 0, we test for point here, you get positive, here you get negative, and here you get positive. So that means it's going up, then down, then up. So that means here it's a maximum, and here it's a minimum. Okay, so now let's see. The options say 1, so when x is 1, we said it's a maximum, so local minimum, that means this is wrong. 3 is a local maximum, we said that 3 is a minimum, so this is also wrong. Okay, this one, we said 1 is a maximum, so this so far could be correct. And 1 is a maximum, this could also be correct. 3 is a minimum, this could be correct. 3 is a minimum, this could be correct. So how do we know which one of these 4 do we choose? Well, they told us the second part of the sentence is saying the second derivative at this point is either negative or positive. Negative or positive. So what we're going to do is just going to derive once again. So that means y prime prime, right? Because they want the second derivative. Okay, so y prime prime is 6x minus 12. Okay, now they said the second derivative at this point, so this point here would be 1, yeah? So the second derivative at 1 is negative. So we'll test that. So we put 6 into 1 minus 12. This gives you minus 6. So far, yeah, it's negative, so you choose it. Okay. Now for this one, here, they said at 3, the second derivative is negative. We'll test it at 6, 3 minus 12. This is actually a positive number. This is positive 6. So that means this one is wrong and this one is correct because it said positive number. Number 10, this is a similar question. First thing we do is derive. So f prime of x is 3x squared minus 12x plus 9. We said that the roots are 1 and x is 3. We'll construct the table. This 1, 3, this gives you 0, this gives you 0. Test a point here, it's positive. Test a point here, it's negative. Here, it's positive. Okay, so it's going up, then down, then up. Okay, so now we know that x1 is maximum and x3 is minimum. Okay, so here you just go through the options. Attains a local minimum at 0. We didn't get to 0, so it just cancelled out. A local minimum at x is 1. At 1 we actually got a maximum, so this is wrong. A local maximum at 0, once again we didn't even get that point, so it's nothing to do with us. Attains a local minimum at 3, yes, this is correct. A maximum at 3, no, it's wrong. A local maximum at 1, this is correct. Last question, number 11. First thing we do, we derive, so it's 12x squared minus 12x cubed. Put this equals to 0, put on your calculator, you get x is 1 and x is 0. Okay, we'll do the table, the x, y prime table. Get 0, 1, this gives 0, this gives 0. Test a point here, it's positive. Test a point here, it's positive. Test a point here, it's negative. I mean, it's going up, then down. Okay, when we have two arrows going in the same direction in order, that means this point here is a saddle point. Yeah, so this is a saddle point and this is a maximum. This one we know. Okay, so it's a saddle point at x is 0 and it's a maximum at x is 1. So we go through the options. They said at 0, 0 is a saddle point. This is correct. At 1, 1 is a stationary point. A stationary point means either saddle, maximum, or minimum. Right? So this could be either maximum, minimum, or saddle. It doesn't really matter, and they don't really care. They're not telling us which one it is, but it is a stationary point, so it is correct. If you go through these other options, x is 2, we didn't even get that. 2 over 3, we didn't get that. 2, we didn't get. 1, 1 is not a saddle point, it's a maximum, so this is wrong.